finger involves the integumentary, circulatory, muscular, and skeletal systems. One system, however, coordinates all the activities of these other systems, and without it, we wouldn't be able to function at all. The nervous system. The organs of the nervous system are few in number: the brain, the spinal cord, and the nerves.
No, that's it. That always does a
The
review.
organs are separated into two divisions:
This is
the
nursing.
central nervous system, or CNS, which includes the brain and the spinal cord, and the peripheral nervous system, or PNS, which includes all the nerves that extend outside the central nervous system and serve the limbs and organs. The nervous system consists of two types of cells: neurons and neuroglia. Neurons are the primary cells of the nervous system. Neuroglia are secondary cells involved in nourishment and structural support. What neurons actually do is transmit signals very, very rapidly. This is accomplished in two ways: within the neuron itself and between neurons. A typical neuron is composed of a cell body, dendrites, and axons. The dendrites carry impulses towards the cell body. The axons transmit them away from the cell body. The contact between one neuron's axon and another neuron's dendrites is called a synapse. You can see how an impulse is transmitted from one nerve cell to another. Some neurons have over 1,000 dendrites apiece, enabling connections to tens of thousands of other neurons simultaneously. There are three main types of neurons: sensory neurons, motor neurons, and interneurons. Sensory neurons connect our senses of touch, odor, taste, sound, and vision to the central nervous system, that is, the brain and spinal cord. Motor neurons transmit impulses from the central nervous system to the muscles and glands that carry out the response. While most neurons are very short, the axons connecting your spinal cord to your foot can be as much as 1 meter long, although only a few micrometers in diameter. Interneurons are found exclusively within the spinal cord and brain. It is estimated that the human brain contains 100 billion interneurons, averaging 1,000 synapses apiece. That amounts to 100 trillion synapses. Electrical impulses travel through neurons at about 100 meters per second. This is equivalent to over 200 miles per hour, the speed of a bullet train. The nerve impulse crosses a synapse in 1/10,000th of a second. Between catching a ball and throwing it again, only a moment later, many millions of neurons may have been activated, and hundreds of complicated processes have sent information, processed the information, and acted upon it. The central nervous system consists of the brain and spinal cord. Weighing about 3 pounds and roughly the size of a coconut, the brain, also called the encephalon, fills the top half of the head and is the largest and most complex mass of nerve tissue in the body. Composed of multiple interacting parts, the brain regulates widely different bodily functions, from involuntary processes like blood pressure, balance, and appetite, to voluntary processes like walking, thinking, and feeling. Specific brain functions are, to some extent, localized in various lobes. Thinking, creating, and control of body movement occurs in the frontal lobes. Sense of direction, recognition of objects and their uses, and collection of sensory data received by the body takes place in the parietal lobes. Located next to our ears, the temporal lobes regulate hearing, speech, and memory. The occipital lobes, located at the back of the head, receive and interpret information from the eyes. In general, sensory information from the left side of the body is processed in the right side of the brain, and information from the right side of the body is processed in the left side of the brain. Among other things, this means that damage to the right side of the brain, caused by a stroke, for example, will affect the left side of the body. The brain stem is the brain's stalk and connects the brain to the spinal cord. It is responsible for such basic unconscious functions as breathing, heartbeat, and blood pressure. 12 pairs of nerves, called cranial nerves, emerge from the brain stem. These nerves primarily control functions of the head, face, and sensory organs, and are part of the peripheral nervous system, which connects the brain to the body. The spinal cord consists of nerve cells and is enclosed in and protected by the vertebral column or backbone. 31 pairs of nerves belonging to the peripheral nervous system branch out from the vertebrae in the backbone. The function of all the spinal nerves is to transmit impulses to and from the spinal cord and the periphery of the body. The brain and spinal cord are constantly bathed in a cerebral spinal fluid that originates from circulating blood plasma. Cerebral spinal fluid also cushions the brain and spinal cord and is found in large spaces deep within the brain called ventricles. The brain and spinal cord are covered by special protective membranes called meninges, which provide support and stabilization of these delicate tissues. The middle layer of the meninges is called arachnoid, which means spider in Greek, because it resembles a spider web. The peripheral nervous system consists of nerves that extend outside the central nervous system to serve the limbs and organs. The peripheral nervous system is divided into two main systems: the somatic or voluntary nervous system and the autonomic or involuntary nervous system. The somatic nervous system facilitates control of body movements. In contrast, the autonomic nervous system is responsible for controlling involuntary functions, also called visceral functions, including digestion, respiration, metabolism, and blood pressure. There are connections between the two systems, however, and thoughts can influence visceral reactions and vice versa, as illustrated by the phrase, "The thought of that makes me sick." The autonomic nervous system is further subdivided into the sympathetic division and parasympathetic division. The sympathetic nervous system responds to impending danger or stress and is responsible for the increase of one's heartbeat and blood pressure. The parasympathetic nervous system is evident when a person is resting and feels relaxed, and is responsible for such things as the constriction of the pupil, the slowing of the heart, the dilation of blood vessels. Most impulses travel from a sensory node like a fingertip to the spinal cord, and then to the brain for processing and response. But some of these impulses terminate in the spinal cord itself. This is called a reflex, and it's one of the body's defense mechanisms that provides for fast reaction. For example, when you accidentally touch something hot and immediately pull your hand away, the heat sensation travels along the sensory nerve to the spinal cord, while the impulse to jerk your hand away travels instantly from the spinal cord back along a motor nerve without engaging your brain at all.
Hello.
Oh, hi.
Hi, good morning. Your name is Chris?
Yes.
Chris, hi, I'm Janelle.
Hi, nice
I'm the
to meet
nurse here at the clinic, and I understand we've got something going on today.
you. Yeah.
Yes, perfect. Okay, well, I'm just gonna wash my hands here and sit down, and I have a few questions that I'll ask you.
Okay.
Okay?
Because the nervous system is directly involved in every other aspect of body function, findings in your assessment may indicate disease or changes in other body systems. The neurologic exam begins with an assessment of the individual's level of consciousness. This actually begins at the first moment of contact. Is the patient alert? Does she understand where she is and why she's there? Does she respond appropriately to environmental stimuli and to questions? And are her answers appropriate? If the above criteria fall outside the expected norm, the patient may require immediate intervention. Otherwise, you'll continue with the assessment.
You said you have some headaches.
Yes.
Have you noticed any events that cause you to have these headaches?
Additional information needed includes whether her headaches are precipitated by specific events or associated with other symptoms, such as vision changes, nausea, or dizziness, and what treatments she uses and their effectiveness. Have the patient rate the range of headache pain using a numerical or other pain scale.
Okay, now, have you ever hit your head or had any sort of an injury that you can recall?
No.
No, you haven't.
It is important to know if she has a history of head injury, and if so, when did this occur? Did she lose consciousness, and for how long? Also ask if there have been ongoing effects of the injury. Forgetfulness and alterations in temperament, including angry outbursts, are just two of the changes that can occur related to head injury.
Do you ever have vertigo or any dizziness?
No.
Okay.
Dizzy spells can be related to a variety of things, from something simple such as sinus or inner ear infection to something as serious as a brain tumor. It can also be a side effect of some medications, such as antihypertensives. If vertigo is reported, ask how often and how severe.
How about a history of seizures?
No.
If yes, ask about the type of seizure, any precipitating events, and if she experiences any indications that a seizure is about to occur, known as an aura. If she is on any anti-seizure medications, record the name and dosage of the medication.
How about a history of strokes or atrial fibrillation?
No.
Strokes and TIAs, or transient ischemic attacks, are cardiovascular in origin, but there are often neurological after effects, making them important to this exam. If the patient answers in the affirmative, ask about the history, and if changes in function occurred, ask if any medications are prescribed.
So you said you have tremors. How about, do you notice any weakness or incoordination at all?
No.
Not at all.
Tremors, weakness, and incoordination may or may not be obvious, or may wax and wane. So it is important to ask about them, as well as observe and test for them in the objective exam. Tremors fall into three categories: resting, postural, and intentional. Resting tremors present when the affected part is not engaged in physical activity and often dissipate upon movement. Intentional tremors are seen as movement is initiated, such as reaching out to pick up a glass. Postural tremors occur when you hold a body part in place against gravity, such as holding your hands out in front of you for a period of time or carrying a cup of coffee. Tremors may be related to excess caffeine, fatigue, and aging, but may also indicate more serious problems, including alcohol and drug withdrawal, brain lesions, hyperthyroidism, and Parkinson's disease. Weakness may affect a specific body part or be generalized. It can be caused by a variety of issues, including metabolic, neurologic, muscle diseases, certain types of poisons, and other disorders, such as asthma and myasthenia gravis. Incoordination, like weakness, can have a variety of causes. Two of the more serious are dystonias related to some drugs, including a variety of psychotropic medications, and brain lesions. Dystonia is characterized by involuntary muscle contractions that cause twisting, abnormal postures, and repetitive movements. It is important to record the patient's perceptions and experiences regarding tremor, weakness, and incoordination, and to later correlate the patient's statements with the findings in your objective assessment.
How about numbness or tingling?
No.
No, it's simply the tremor.
Numbness and tingling are most commonly felt in the extremities, particularly the fingers, hands, feet, and toes. Causes can be as simple as lack of movement, often accompanied by direct pressure on the affected part. The phenomenon is usually referred to as having a part go to sleep and then tingles as the individual moves and circulation resumes. It can also be related to a variety of disorders, so it is important to ascertain how often it occurs, what areas of the body are affected, whether it resolves or is persistent, and whether it is mild and merely annoying or strong and even painful. As mentioned earlier, the neurologic system affects and is affected by all other body systems. So it is important to have a complete list of any medications, current conditions or illnesses, and current treatment regimens. Recent disruption of the normal sleep pattern, alterations in activity tolerance, changes in thought patterns, including increasing forgetfulness, confusion, and a reduced ability to cope with the stresses of everyday life, may all be related to neurologic dysfunction. Answer any questions the patient may have following this portion of the assessment, and then provide her with a gown and privacy so that she may change for the objective portion of your assessment.
We have the second half. I'll have us watch it when we get back from lunch.